You ever been driving and all of a sudden a truck comes along and just pours out black smoke from the exhaust? And you just sit there and wonder, what the hell is that? Well, that's diesel, my friends. Only diesel engines do that. You won't see a gas motor do that. We live in North Idaho, they're all around us. You can't walk 10 feet without overhearing a discussion about diesel engines, gas engines, ATVs, dirt bikes, snowmobiles, all of that stuff. So hopefully today, learning some of the small things and knowing some of the small terms and lingo may help you understand and not feel left out of the conversation if you don't know exactly what they're talking about. Personally, I have gone through 2 years of diesel technology school. I've done all the diesel requirement parts. I just have a speech class and my math class left, and then I have my degree, and that's it. But as far as the actual classes concerning diesel, I've done all of that, everything I can. Today, I'll be going over the differences between a gas and a diesel engine. They're very similar. They have a lot more in common than you might think, and I'll be explaining all of that today. So I'll be going over the 4 and 2 strokes of a diesel engine, the differences between a gas and diesel motor, and why diesels are used for a specific application or purpose. So there's 4 strokes in a diesel engine. There's also 4 strokes in a gas engine. So you have your intake stroke, which is, if you imagine a cylinder, and then you have a piston, which is just like a little smaller cylinder inside of a bigger cylinder. And so when it comes down, it's creating a vacuum and sucking in air. Intake valve opens, it's just a little valve. It opens up at the top. Air is coming in because it's creating a vacuum and it's pulling down. And then as it's coming up, it's called the compression stroke. So this is the second stroke, compression stroke. And as it's coming up, it goes all the way up to the top, and it goes to TDC, which is called top dead center. It's a very small gap between the very top. So like the piston doesn't exactly smack the top of the head, but it's very close. On compression, both intake and exhaust valves are closed. So that way, there's no air leaks, and it's compressing all of the air and fuel in there. Now you have your power stroke. This is your third stroke. Power stroke is once it's compressed so much. The compression ratio in a diesel motor is so high that once it gets up to the top, it compresses it so much, it heats up so much that it actually creates a spark of its own, and it explodes all that fuel and air and shoots that piston all the way back down to the bottom of the cylinder. It's called BDC. And then next you have your fourth stroke, which is exhaust stroke. So exhaust stroke, after it's coming down from the power stroke, it comes back up. Exhaust valve opens, and it pushes all of that air out the exhaust valve. And then after that, it comes down. Exhaust valves close. Intake valve opens, and it's just an intake stroke. So then the whole process just repeats again. Then you have naturally aspirated and turbo. Naturally aspirated just means it's sucking in air. Nothing is helping push air into the motor. A turbo is just a way of helping push more air into the motor. It's just shoving air into the engine. And then for the 2-stroke, all you guys know dirt bikes, 2 strokes, 4 strokes. There used to be 2-stroke diesel motors, and it's the exact same thing, but it's just like a 4-stroke, except 2 of the strokes are combined. So your exhaust and intake are combined, and your compression and your power stroke are combined. It's a little bit harder to explain without being able to draw it up, but that's just the 2 strokes of how they're combined. So the difference between gas and diesel, obviously, like I went over, there's internal compression ignited versus spark ignited. So compression heats up so much, spark, boom. Gas motor, it gets all the way up to the top or near the top, and then the spark at the very beginning of the power stroke, like I mentioned, it shoots off a spark, and then that's what ignites everything and then shoves the piston down for the power stroke. which is what creates all of your energy and all your power. That's where all your power comes from. A lot of gas engines are naturally aspirated, which means they don't have a turbo or a blower motor, supercharger, whatever. Which means there's nothing helping shove air into the engine. It's just all vacuum, like I said in the intake. Diesel motors make almost zero power without helping shove air into the engine. They need help putting air into the engine, so they use a turbo. Otherwise, they make very little power and very little torque. The difference in size, gas motors are generally very smaller. There's smaller diesel motors, but it's not very common. There's anything big is usually a diesel motor. That's why, loaders, excavators, skid steers. Actually, skid steers aren't even that big motors, but like all your heavy equipment is all diesel engines, and there's a reason for that. Torque and horsepower. Horsepower, you imagine supercar, Lamborghini, Ferrari, they're very fast. They have a lot of horsepower. They go very fast. So that just kind of explains horsepower. Difference with diesel engines, they don't make a lot of horsepower, but they make a lot of torque. Those supercars, like I mentioned, they don't make any torque. The torque is the ability to, in simple terms, the ability to push or pull an object. The motor is able to create so much power that nothing's going to slow it down to where it can keep going and push something or pull something. Which is why semis and stuff are all diesel engines, because they pull. Diesels just have more torque because of the design of them. The piston design, the crankshaft design, the whole engine block, it's stronger, it's heavier. It's built out of thicker and stronger material, and it lasts longer. And they last longer than gas motors too, because they run at lower RPMs, and diesel engines are built to last. I mean, it's not uncommon to find a semi and it's over 1 million miles. That's just not uncommon at all. You'd never picture that on any gas motor. So really, I could go all day talking about the pros and cons of a diesel motor, the engineering of it all, every little piece, but unfortunately we have very limited time together. So to restate kind of what I went over today, I went over the strokes of a motor, the 4 and 2 stroke design. Mainly focus on the 4-stroke design because that's kind of what everything is nowadays. Nothing is 2-stroke. 2 strokes are older design for diesels. We went over spark ignited versus compression ignited, the real big difference between a diesel and a gas motor. But the order is kind of the same: intake, compression, power stroke, and exhaust. And all in that same order. And then we also went over why diesels make more power. So overall, diesel motors have a ton in common with its gas counterpart in the order of operations of how an internal combustion engine works, which they're both internal combustion engines. But today I hope you learned the smaller and really important details that really separates the two. Thank you.